So you tell me when you can see my screen. Hopefully you'll see it here in like a second. Did you guys see it?
Yep.
Okay. All right, so I'm going to try to do sort of like a side-by-side so I can still kind of see you guys, but then also do the examples. All right, so hopefully you have like a piece of paper or something to write with. This is going to be our first problem. I'll give you a sec to write it down. So far with the rational functions, they're basically fractions. And they're going to have polynomials within the fractions, maybe on top, maybe on bottom, maybe both top and bottom. And your last assignment was just to simplify. You only had one fraction and you just had to simplify it. And you had to probably factor and cancel stuff that was the same on top and bottom. Now what we're going to do is we're going to incorporate that as well as adding or subtracting the two fractions. So it's going to all kind of come together, but we're going to still do it in like step by step. So anyway, if I'm looking at these two fractions, the only way that I'm going to be able to add them is if I have common denominators, and right now they do not have common denominators. So typically a good way to figure out what the common denominator should be is to look and see if anything will factor. Factoring also entails taking out a common factor. So like if I'm looking at this fraction here, x plus 3, that's pretty basic. There's nothing extra there. But over here, 5x plus 15, they have something in common. So I want to take out the thing that they have in common. So I'm going to rewrite everything else just to get it set up here. Okay, so what do 5 and 15 have in common that we could take out? Yeah, so I'm going to take out that 5. And then what would be left over is, yep, you got it. Okay, now, do you see how this fraction over here already has an x plus 3? So in order to have a common denominator, I have to multiply this fraction by 5, because it's missing the 5. I have the x plus 3, but I don't have the 5. So maybe I'll use a different color here. I'm going to multiply by 5 on top and bottom, because if you're multiplying by the same thing on top and bottom, you're essentially multiplying by 1, because 5 divided by 5 is 1, and that doesn't change the integrity of the problem at all. So here's what I got right now. I've got 2 over 5 times x plus 3, and over on the right, I got 5 times 5, so that's 25 on the top. And I have that common denominator. So now that I have common denominators, I can add them up. And whatever is the common denominator stays that denominator. So we just leave it as 5 times x plus 3. But then we add the tops. So I'm going to add 2 plus 25, and I'm going to get 27. And this doesn't reduce any farther because 5 doesn't go into 27. So it's not like I can cancel with the 5 down here at all. So that's it. Doesn't reduce any farther. So just to kind of recap what we did was we took out a common factor of 5. All right, so we did that first, then we realized this fraction needed to be multiplied by 5 in order to get that common denominator. Once you have the common denominator, that's it. Just add the tops. All right, any questions on that before I try another one? Okay. If you do have a question, feel free to unmute yourself and just go ahead and ask. That's the whole purpose of the live session, so you can actually ask some questions. All right, so here's the next one. Again, we're adding fractions. We have to have a common denominator. I'm looking at the first fraction here. I just have an x plus 6 in the denominator. There's nothing crazy about that, nothing special. There's nothing in common that can be taken out, so I'm just going to have to leave that. But over here on the second fraction, look at the bottom. Do you see what they have in common? Yeah, so you can take an x out. So I'm going to rewrite the first fraction, and I'm going to rewrite the top. Okay, now I'm going to take out that x that you said that they have in common. And then we have to look at what are we going to have left over. So like x times what would make this x squared? That would have to be an x. And then x times what would make a 6x? Yep. Okay, so there you go. Do you see how both denominators have an x plus 6? But what's this first fraction missing then? Yeah, so we have to get a common denominator by multiplying this fraction by x. So now I have 10x over my common denominator of x times x plus 6. And then I'm just rewriting this other fraction over here. Now you can maybe see a little bit better. They both have that same common denominator. So that is my denominator for my final answer. And then all I have to do is add the tops. So I have 10x plus 2. And those don't combine because the 2 does not have an x. So you just leave it like that. So just to kind of recap this one, we took out the thing that they have in common. And then we needed this fraction to have that x as well so that they had a common denominator. Any questions with that one? All right, here's the next one. Little twist to this one. This one's a little different. So again, whenever you're adding or subtracting, you got to have a common denominator. This first one just has an x minus 5. Again, there's nothing special about it. There's nothing extra. There's nothing they have in common to take out. When I look over here, it kind of looks the same way. It kind of looks like there's nothing for me to take out, right? This doesn't have a 5 or a 25. They don't have anything in common. But what you got to remember is back to when we were learning how to factor stuff. The bottom of this fraction factors. So this is difference of squares. The giveaway is that we have an x squared, so it's a quadratic. So it might factor. And factoring, you know, remember, is like when you've got your two sets of parentheses. Also, when you have a subtraction sign, this only works for subtraction. That's why it's called difference of squares. So it has to be two terms with a minus sign. And the numbers have to be perfect squares, meaning when you take the square root of them, you get a nice number. It's like when you take the square root of 25, you get 5. So what happens, I don't know if you remember this, but what happens is when you factor it, they're going to look identical, except one will be a plus and one will be a minus. So here's what I'm trying to say. They're going to look identical, except one will be an x plus and one will be an x minus. And then what two identical things make a 25? Yeah, so this will be an x plus 5 and this will be an x minus 5. You've done that before. You've done that factoring before, but it's been a while, so it's possible you might have forgotten a little bit. Okay, so now that we have the denominator factored, now you might be able to see easier, what do we need to do to this fraction to get them to have that common denominator? What's this one missing? Yeah, because we have an x minus 5 already, just like over here, we have an x minus 5. But this guy is missing an x plus 5. So then I'm going to multiply by x plus 5 on top and bottom to get that common denominator. Okay, I'm going to rewrite the second fraction as is. I'm not going to do anything to it yet. The first fraction, I'm just going to kind of clean that up a little bit. So my common denominator on the bottom is the x plus 5 times x minus 5. I'm just rewriting that. Now on the top, you got to clean this up. So we are multiplying x plus 5 times 3x. So we have to distribute that 3x through. Not quite. Remember, we're multiplying. So we have a 3x times an x. So maybe if I write it down here, a 3x times an x, that would be a 3x squared. If it was 3x plus x, that's 4x. That might have been what you were thinking. But we're multiplying when we distribute. So 3x times x is 3x squared, and then we have to do 3x times 5. So 3 times 5,
15.
Yep, you get 15x. Okay, so now we can actually combine these two together because we have a common denominator. So that common denominator will stay your denominator. And then all we do is subtract the tops. So I have 3x squared plus 15x, and then I've got that minus 2. And now the top here is a quadratic, and we have learned how to factor that, but this one actually doesn't factor. It doesn't work. What we will eventually get to later is factoring the top, because that might have a factor that cancels with the bottom. But in this case, it doesn't. This does not factor. So that's as good as it gets. That's your answer right there. Nothing cancels in this one. Eventually, we will do problems where things will cancel. That one was a trickier one because we had the difference of squares. You got to get that factored. Then when we get our common denominator here, we had to distribute the 3x. That's tricky. And then combine once you have your common denominators. We're going to do another one kind of like this, okay? Do you need a sec before I go on to the next problem?
Would it be okay if you did none of the homework problems?
I am going to, the problems that I'm doing here in the notes are just like the homework problems. So I'm going to go through all of these first, and then the homework should make sense. And I want you guys to try the homework as best as you can. And then next week, if it doesn't go well, I can like make a video going over it or something, or you can come to office hours. Or you could come to office hours today. I got office hours from 11:30 to noon. Although I think I have posted 11 to noon, I'll just do that. I don't care. So after the notes here, if the homework still doesn't make sense, come to office hours. But I think it will. I tried to make the homework just like the notes. Okay, here's another one. I got 6 examples, so we're on number 4. So this one is very similar to the last problem. So this denominator right here, you see how you got a term that's being squared? It's a quadratic. You have 2 terms with a minus sign. And 36 is a perfect square because the square root of 36 is a nice number, 6. So this is difference of squares. It's going to factor. And when it factors, it will factor like they'll look identical except one will be a plus and one will be a minus. So what two identical things would multiply to a 36? Same exact numbers. What times what equals 36?
6.
Mm-hmm. Okay, now look at the other fraction over here. Do you see how that has an x plus 6 in the denominator? So this one over here has an x plus 6 as well. So what's this fraction missing? What do we need to multiply it by so that it has the same denominator? They both have an x plus 6. This one has an x minus 6. That,
X minus 6.
yep, so that's what you need to do on the top and the bottom. I'm just going to rewrite it. I'm showing all the steps. Eventually you're going to get to the point where you can maybe skip. But I'm just going to show all the steps for now. So on the top here, this is what we need to kind of fix up a little bit. Now you're multiplying by 1. So yeah, I mean, you do technically need to distribute the 1 through. But multiplying by 1 doesn't change anything. So, I mean, I have 1 times x, which is just x, and I have 1 times negative 6, which is negative 6. I'm ready to add them up because I've got common denominators. That will be the denominator. And so now we add the tops. So I have 15x, and then I've got plus x, and I got a minus 6. Now that does simplify a little bit on the top, because you see, yep, because you got common terms here. You've got these are like terms right here. They both involve x's, so that'll be 16x minus 6. And there's nothing common between the 16x and the 6. There's nothing that can be taken out. Nothing's going to cancel. That's as good as it gets. We should always try to simplify if we can at the end, just like you did on your last homework. But so far, nothing has. I did that on purpose, FYI. One thing at a time, right? We're trying to get this whole common denominator thing figured out. Okay. All right, here's number 5. This is 5, and then we're doing number 6, and then we're done with the notes. Okay, so just looking at it, what denominator do you think you could kind of work with here? Like, which one has something that can... Sorry, I didn't hear you. Say it again. This one right here, the x squared plus 5x, or this one here, the x plus 5?
X plus 5.
So this needs something extra, right? Because like this has a squared, this has an x on it. This has some extra stuff that this one does not. Okay.
Yeah, so does it need an x?
Yeah. So if you look at the first denominator here, they have an x in common. So that x could be taken out. And that might help you see. So like if you take an x out, you'll still have an x. X times x is x squared. X times 5 is what would give you this 5x here. Think about like if you were distributing the red x through, you get this original denominator. Factoring it out like that just kind of helps you see, oh yeah, they both have an x plus 5 in common, but this one has an x, this one does not. So Alana, you're right. You need to multiply this fraction over here by x. Now they have a common denominator. So the common denominator is x times x plus 5. We can add the tops. I got a 15x plus a 3x. And those will combine because they're like terms. So if I have 15 x's plus 3 more x's, I'm going to get 18 x's.
For the 15x, why did you put an x in front of it if it already had the denominator that you wanted?
This x, this red x right here,
Yeah.
I pulled it out of these two. So this term has 2 x's and this term has 1 x, and I took it out in front.
So if we add an x to the 3x over x plus 5, is that wrong?
No, that's what I did over here to get a common denominator.
Why would we write it as x squared plus 5x?
You can do that. Sure.
So if you write it like that, it's not considered wrong.
Well, it's not wrong, but you're not going to see how things cancel. Because like at this point right here, something will cancel. Like this.
So for all the problems, we have to write it with the x on the outside.
I would suggest that you do, because then you're going to see what cancels better. So it's best to have everything factored. Factored can mean having the 2 sets of parentheses, but factoring can also mean taking out a common factor. Because in this problem right here, we're not quite done. Do you see how you're multiplying by an x on the top and you're multiplying by an x on the bottom? Those x's will cancel. So you're going to have 18 over x plus 5. That would be your final answer. And you won't see that if you leave the denominator as x squared plus 5x. You might not see that the x's cancel. So I typically factor anything that's common out, like we did this x here. It looks like there's a comma. It's not a comma. I was kind of gonna circle it, but I'll erase that. So if you take out a common factor, in the end, it sometimes will cancel. Not always, but sometimes it does, and it's just kind of easier to see what's going to cancel if it has been factored out.
So if it would have been 18 plus x, you couldn't have canceled it out?
Correct. Yes. Yeah. You can only cancel if you're multiplying by the exact same thing on top and bottom.
And then if it was 18 squared x, you can't cancel that out, or can you also cancel out the 1 inside the parentheses?
Like 18x squared?
Yes.
Over like this?
Yeah, does that mean you can cancel out both the x's that are down there?
No. So the top, like, okay, so this is a side note, everybody. This is not part of the problem. This is just like a what if. Okay, so the top, I could write that as 18 times x. And I would only be able to cancel one of the x's from the top and the bottom. Because now this x right here is being added to the 5, and we can't cancel it. It has to be, like, right now then, here's what we would have. And you cannot cancel these 2 x's because this one is not being multiplied. You can only cancel if they're common multiples. So you had 2 on top, you have 1 on bottom. You can only cancel 1 from top and bottom. So is everybody clear that this is the answer to that problem? Okay. All right, here's the last one. And then if you have extra questions after this, it's totally fine too. But technically we've got 3 minutes until 10 o'clock. So if you need to go at 10 o'clock, you can. So we should be able to get this done. All right, so this first fraction, there's nothing crazy happening. It's really basic, simple. But the second fraction, you see how there's more stuff going on down here? This is a quadratic. Quadratics don't always factor, but they do a lot of the time, and I'm giving you problems that are gonna factor for the most part, just to get you used to that. So we're gonna try to factor this. You had problems like that on your last homework. So let's try to factor it. Let's try to think of what multiplies to 6 and adds to 5.
6 and -1.
Except it has to multiply to a positive 6, and those two would multiply to a -6. So that option won't work. It's got to be either, okay, so things that multiply to 6. 6 and 1, they'd have to both be positive or both be negative.
2 and 3.
Yep, or -2 and -3. Okay, so out of all of those options, which one adds to 5?
2 and 3.
Yep, so it's x plus 2, x plus 3. Okay, so do you see how, oh, look, at this one has an x plus 3, just like this one does? But it's missing the x plus 2. So that's what we need to multiply by on top and bottom. Now they have that common denominator. I'm going to fix this first fraction up a little bit because I'm doing x plus 2 times 7. That 7 needs to get distributed. So 7 times x would be 7x. 7 times 2 would be 14. All right, now they got common denominators, so I can combine them. And that will be my common denominator. And now I just deal with the tops. So I have a 7x plus 14, and then minus 4. And then that simplifies. Because on the top, I've got these two that are like terms here. 14 minus 4, I can combine those. So 14 minus 4 is 10. So I have 7x plus 10 on the top. And there's nothing in common. 7 and 10 have nothing in common. I can't take anything out. Nothing's going to cancel. So that's it. So here's the thing. Every single problem that I'm giving you today, when you have to factor like this, you're going to notice, oh, one of them is the same as the other fraction's denominator. They're going to have part in common for all of them. And so if you're doing a problem and you're noticing that they don't have anything in common, then you're making a mistake. So like once you factor this one, it had an x plus 3 just like this one did. Or this previous problem, when you take out an x, you realize, oh, they both have an x plus 5. Or here, when we factored this difference of squares, we realized, oh, this has an x plus 6 just like this one did. So they're going to have something in common, and then you're in charge of multiplying by something to get them to both have the exact same denominator. So like this one here, it was difference of squares. Oh, we saw they both have an x minus 5 in common. This guy needed an x plus 5. Take out an x. They both had an x plus 6 in common. This guy needed an x. So kind of expect that on the homework. They're all designed to be that same kind of way. So it's 10:01. If you need to leave, go ahead. But if you want to stay, if you have any other questions, feel free to ask. And like if you want me to make up another example, I can. But yeah. So